Hello guys, welcome to all of you on my YouTube channel. This is Samadhan Kale and we are going to see in this video guys the third year BSc Mathematics practical number 5 of the subject Python programming. So guys, this is a practical 5, that is application of matrices, and this practical is based on unit 4 of the points 4.1 to 4.3. So guys, before starting today's video, if those of you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get latest update of videos. So let's start the video guys. So this is our first question, that is explain the SIMPy library guys. Okay. So SIMPy means guys in general, SIMPy means it is a scientific Python. Yes, it is a, sub library of scientific Python, that is the SciPy. Yes, SciPy. And this simply means symbolic Python. Yes, it is used for symbolic Python. So symbolic Python means what guys we have to do here: calculus and linear algebra and physics, chemistry, and all these things. Yes, so SIMPy is a Python library and it is used for symbolic mathematics. So it aims to become a full-featured computer algebra system. Yes, it is based on the computer algebra system and on this thing. Okay, guys. So this is the thing. So guys, it's the SIMPy library and it is totally depends on the MP math, and it's the pure Python library for arbitrary floating point arithmetic. So firstly, guys, we will see how to import this library in Python. Yes. So installing SIMPy library module. So how we can install this SIMPy module in our Jupyter Notebook or IDLE or any platform that you have used. So you have to give this command on the command prompt or Jupyter Notebook or anywhere that is used. You have to use that platform to run the program. So you can type this command, that is a pip install simpy. Yes, pip install simpy. Then it will be installed. That is the simpy library will be downloaded and it will be installed. So this simpy library is used as a calculator. It is used as a uh, symbolic mathematics, that is a number, limits, continuity, differentiation, integration, and all these things. Yes. So I have given here it's used as calculator only. Okay. And we can use it in mathematics more. Yes. So this is double I think. Okay. So you have to cut this one. Okay. I will cut this because it's doubly. That's why don't write this one on your sheet. Okay. Yes. Now I will run it. So this is the thing, you have to write only this one. And also you can add in this explain simple library, you can write it as this simple library can be used as used for operating on linear algebra, physics, chemistry, and symbolic mathematics. Symbolic mathematics means what guys? That is uh, calculus. Calculus means limit, continuity, differentiation, and integration. So this is our first question, guys. Now let us move to the second question. So second question says that explain the RREF function with suitable example. So what is this RREF function, guys? RREF function means reduced row echelon form. We have to find the reduced row echelon form of the any matrix. We can use this function RREF. Then we can find the reduce row echelon form by using this function. So with the help of simpy.matrix rref method, we can put a matrix into reduced row echelon form. That means we can find the reduced row echelon form of the particular matrix by using this function. So the first is the reduced row echelon form, and the second is a tuple of indices of the pivot column. Okay. So what it will be give? We will see by example. We have to give the example also, guys. Yes. So this is the syntax I have given here. Matrix. That means any matrix that you have to take, you can take it. Matrix dot rref. Okay. So let's take, guys, firstly we have to import the library. Okay, so from this library, simpy library, from simpy I will import the matrix. Yes, so import the matrix function. Okay, so this is the matrix function. So guys, if you do not seen the linear algebra topic or the linear algebra course on my channel, you can see it. I have given the link of that course in the description box. You can check it and you can learn the linear algebra using Python in detail there itself. Okay, so matrix, we will take the matrix A is equal to by using this function, matrix function. So this is a matrix, and suppose I want to construct a 3 cross 3 matrix. Okay, and then I will use the element as 1 2 3. Okay, 1 2 and 3. Then fourth element is my -1, then 0, and then 2. Okay, then 1, and then -2 and 3. These are the elements, guys. Okay, now I will print the matrix A, and if I run this, so let's see, I will get the matrix or not. Let us see what is happening here. 1 second, I have to check it. 3 and these 3, 6 and these 3, 9 elements are there. Yes, yes, itself I have to give the comma. Okay, let's run it, and I will get the matrix A. Now, if I want to find a reduced row echelon form of this matrix, so I can find it, guys, by using this function RREF. So I will use A dot RREF function, reduced row echelon form. Okay, and if I run this, so I will get the matrix. Let us see. This is a matrix 1 0 0 0 1 0 and 0 0 1. Okay, this is the reduced row echelon form. And lastly, what he says it will return a tuple. It will return a tuple of which first element is a type of matrix, is of type matrix, and second one is type tuple. So first element is matrix and second is tuple. This 0 1 2 is the tuple. Okay, so this is the output. Now let us move to the next question, guys. So this is our third question. So for vectors u and v, we have to calculate this one, guys. Okay. So firstly, we will import these vectors. U is equal to, okay. But see, guys, these vectors are the column vectors. These are not a row vectors. I have converted these vectors into the row because of this problem of column vectors. Okay. So in Markdown, I could not convert this column row matrix into column. Okay. That's why I am taking this in the row. Now I will take matrix function for this. Okay, so matrix of what? This first one, 2 5 and -3. Yes, 2 comma 5, and this is the -3. So this will be a vector. Okay, that is the column vector. And second one is b is equal to, this is the matrix. Okay, and it's again 1 0 and -2. Okay, so these are the two vectors, guys. And if I run this cell, so these two vectors are get imported. Now, firstly, I want to calculate u plus v, guys. Okay, so I will take u, then it will give me the vector u. Yes, then if I print v, then it will give me the vector v. Okay, now firstly, what we have to do, we have to calculate u plus v, u minus v. Okay, so simply we can substitute here u plus v, u plus v. Yes, and run it. So this is the column vector again, u minus v. It will be again a column vector. Yes, and then next one is, guys, what is next one? I will take it here. Yes, I will take one cell. Okay. And what is the next? Next is a 3 into u. So you have to multiply the scalar 3 to the vector u. Okay, so 3 into u. And if I run this, so this u is multiplied by 3. 2 3s are 6, 5 3s are 15, 3 3s are 9. Okay, then lastly, what we have to do, guys? We have to do 2 into u plus 3 into v. Okay, So we can write, if we write as a print function, then what will happen? Let's see, guys. If we use the print function, and in this print function, if I use 2 into u, okay, and then plus is 3 into e, and let's run it. So I will get this in the matrix form. Okay, so it is not visible. Yes, now this is the matrix visible. So we have to do in this way. Don't use the print function. So this is the question, guys. Let's move to the next question, fourth question. So construct the following matrices. We have to construct the identity matrix of order 3, zero matrix of order 2 cross 3, and ones matrix of order 4 cross 4. Okay, guys. So again, I will request you to see the videos of linear algebra. Okay. In that linear algebra videos, I have explained all these things in detail. That means how to construct a identity matrix, zero matrix, and all these things. Okay. So for construction of identity matrix, guys, there is a function known as I function. By using this I function, we can construct a matrix. Okay. So I will use this simple library again. So I have imported this library. So so dot, I will use the I function, and in this I function I will write 3. That means I will construct the identity matrix of order 3. So 3 cross 3 identity matrix is constructed here. Okay. Now let us move to the second, that is the zero matrix of order 2 cross 3. Now there is again a function in the simple library, and which is known as zeros function. Which function, guys? Zeros function. So by using the zeros function, we have to give the order. Here we ask the 2 cross 3. So we will give the 2 comma 3, and it will give us the zero matrix of order 2 cross 3. That means 2 rows and 3 columns. Okay. And the last one is ones matrix of order 4 cross 4. Okay, there is again ones function, guys, in the simple library. So I will use that ones function. And what you have to do, you have to construct a ones matrix of order 4. So you can give the 4 itself. So you will get the 4 rows and 4 columns, and each element is 1, guys. Okay, so this is the question. Now let's move to the fifth question, guys. So for the following matrices, we have given these two matrices A and B, and we have to perform these operations on the matrix A and B. Okay, so firstly, I will take the matrix A as A is equal to the matrix. Yes. So this is our matrix. And in this matrix, I'm going to take, it is a 3 cross 3 matrix. So that I will take as 3 cross 3. And then I will give the elements 1, then 2, then 4, then 1. Okay. Again, that is the minus 1, 1, and 2, then 4. Okay. And lastly 2. So this is our matrix A. And if I run this A, yes, if I run this A, so I will get the matrix A. Okay. Again, I will take the next matrix, that is matrix B. So what is matrix B? So I will use it as B is equal to, I will use the matrix function. So it is again a 3 cross 3 matrix. So I will use 3, 3. And in this list, I'm going to take the elements of the matrix B. So the elements are 1, then 5, and then 3. Yes. And then again 3, then minus 7. Okay. And then 5, then 3, then 1, and minus 1. Okay. So this is our matrix B. And if I print this matrix B, so I will get the matrix B. Okay. 1 second. I have to give here comma. Yes. Let's run it. So I will get the matrix B, guys. Okay. So we have to find first 2a plus 3b. Okay. So I will give the command like this. So we have to find 2 into a. So I will use 2 into this capital A plus 3 into b. Okay. So 3 into b. And if I run this, so it will calculate 2 into a first, then 3 into b, and add them. So this is the program. Next one is 4a minus 3b. So we have to use only, we have to give the that operations only, that is a 4 into a minus what, 3b. Okay, minus 3 into b. And let's run it, guys. If we run it, so we will get the output. Okay, and then next one is a minus 2. Okay, I'm taking here, you have to write this sequentially one by one. Okay, so I will take as a minus 2. Then let's see what will happen. I will get an error. I will get an error. So why error, guys? Because this int object, that means it is a only one integer. Okay, and if I take, instead of this, if I take the identity matrix of order 3 by 3. Okay, so how I can take it? I can take it as 2 into SO dot identity matrix of order 3. Then what will happen? Let's see. It will give me the output. Yes. So a minus 2 into I, if we consider, then I will get the output. Next one is, guys, b into a. What? B into a. So we will simply use b star a. Yes. And then it will be multiplied. Matrix b is multiplied to a. Next one is, guys, b inverse ab. What? B inverse AB. So what we have to do, guys, there are two methods. There is an inverse function in this SPPU library. We can use that inverse function also. And instead of inverse function, we can use a double star minus 1 also. Okay. And then this multiplied to the matrix A. Again, this is multiplied to the matrix B. And let's run it. So we will get the B inverse A into B. So this is the calculation, guys. Okay, I hope all of you understood this question. Now let's move to the last question. So we have to take this matrix C. Okay, firstly I'm going to take this matrix C as C is equal to the matrix. Okay, and then it's again a 3 by 3 matrix. I'm going to take the 3 by 3 matrix, and I'm writing the elements minus 5, 2, 3, again 3, and then minus 7. Okay, then 5, then minus 3, then 10, and lastly the minus 11. Okay, so this is my matrix C. So if I print this matrix C, so I will get the matrix C. So what I have to do, guys, I have to delete the second column. I have to delete the second column. So guys, in this SPPU library, there is a delete column method. Okay, or column delete method. Column delete method. By using that method, we can delete the column. If I substitute here dot, and if I press the tab button of my PC, then it will give me the methods. Okay, and I want to use the column delete method. Okay, so let us see, it's the column delete method. Okay, so in this column delete method, which column I have to delete? Second column. Second column. That means, guys, second column means it is a 1. We have to give the order. Okay, and if we take again the matrix C, then we will see the second column will be deleted. Let us see, this this 2 minus 7 and 10 is not here. Okay, now next question is, guys, what is next question? Add row r is equal to 2, 3. We have to add this row into this matrix C now. Okay, so there is a row insert function, guys. Okay, so I will use that function C dot. Okay, if I use the tab and then row. Okay, and this is the insert. Okay, we have to insert the row. So by using this function, we can use this row insert. Okay, C dot row insert, and which row we want to insert? 2 and 3. Okay, so give that here 2 comma 3, and let's run it. Let's run it. Row insert missing one positional argument. Okay, so if we check this, as which argument we have to give? position we have to give. Okay, so which position we have to give? 0, 1, 2, 3. Okay, if I give the 3 here, so it will be inserted to the third position. Let us see what is happening. List object has not columns. Yes, 1 second. If I give here 0, then it's again give me error. 1 second, I will check it. So guys, what I have to do, I have to insert this row by using this matrix. So firstly, I have to convert this row as a matrix form. Okay, so I'm taking this row into the matrix, that is a 2 3, and if I insert this row at 0th position, so it's inserted at 0th position. If I want to insert this row at a 3rd position, then it will be inserted to the 3rd position. Let's see, -5 3 3 5 -3 11, and this 2 3 is inserted to the last. Okay, and what is the last question, guys? Last one is delete the last row. We have to delete the last row. So again, there is a row delete function. Okay, if I give the tab, then row, okay, and underscore, oh sorry, tail row function, tail row. Okay, like of tail column, it's a tail row function. So by using this function, we can delete. Okay, no attribute. 1 second, I want to check whether it's delete row or row delete. Okay, so that we will get. Now if I use row, yes, it's a row delete function. So in this row delete function, which row I want to delete? Last row. Okay, so if I give 3 here, then what will happen? Let's see. Okay, let us see. 3 is out of range. Okay, if I give the 2, then it will be deleted. And if I print C again, then what will happen? Let's see. It will give me only 2 because I have run already that one. That's why. Doubly. I have run the function doubly. That's why it's taking. It's deleted last 2 rows, -3 and -11, 2 and 3. So this is the function, guys. Okay. So what you have to do first? Okay, I will run this once again so that you will not confused. Okay, matrix C, then C column delete. Okay, then this is again this one, okay, and then C. Okay, so it is the thing. Okay, if I want to delete again, if I run this, then it will not give me anything. Okay, positional argument I have to give. So if I run the 0, so it's deleted now. Okay, again it's 3 and 5. And if I give again 0, then it will be a empty matrix. Okay, I hope guys all of you understood this practical fifth. So thank you for watching the video.